Welcome back, grade 12s. We are looking at number patterns where we are on video 2, where we're going to handle quadratic number patterns. Just a quick reminder that this resource is copyright protected. So when we look at the quadratic number pattern, the all too familiar d of n is equal to an squared plus bn plus c comes to mind. This formula you are very familiar with already from grade 11, but it also ties in with the quadratic function, the parabola, ax squared plus bx plus c. So nothing new to it, it's just that it is written because it is number patterns. We work with term numbers and therefore we use the letter n. So let's look at this information. So if we have to calculate the first term, we will substitute the n with 1, n with 1, n with 1, expand and get a, b, c. If we have to find the second term, we'll substitute with a 2. So 4a plus 2b plus c. We have to find the third term, will be 9a plus 3b plus c. And the fourth term would be 16a plus 4b plus c. So if we have that and we want to find the first difference, remember quadratic number pattern has got a constant second difference. So if we want to find the first difference, I need to find then the difference between term 2 and term 1. So I subtract them from each other, and notice that I put a plus b plus c in a bracket, which means I have to apply the negative to all of these. And then I get an answer here of 3a plus b. If I take term 3 minus term 2, that guy minus that guy, 9a minus 4a is 5a, 3b minus 2b becomes b. And the fourth term minus the third term, 16a minus 9a is 7a, and 4b minus 3b is b. Now to go to the second difference, I need to take the difference of term, the second term in this sequence that is formed here, minus the first term. So it's the difference, the first difference, the second difference. So the second difference minus the first difference will give me 5a minus 3a gives me 2a, and b minus b will cancel out. Then 7a minus 5a will give me 2a, and b minus b will cancel out. So I'm left with 2a and 2a. Remember, a quadratic number pattern has got a constant second difference, and that is where we are at this point in time. So if I'm working with the first term, if I was given the first term, I will say that the constant second difference must be equal to 2a. The difference between the first term and the second term must be 3a plus b, and the first term will be a plus b plus c. But if they gave me that the pattern started at the second term, I will still use the 2a is equal to my constant second difference, but my difference between my second and third term will be 5a plus b and not the 3a plus b as I always use. And my first term will not be a plus b plus c, but it will be the second term then that is equal to 4a plus 2b plus c. And that particulars needs to be focused on very meticulously. And this will continue in this fashion even if it goes to the third term, fourth term, etc. But the most important thing to remember is when I'm given this information, try to work back to your first term that you do not have this problem. Even for the C value, to find the C value, you could go back to term 0 and you will find that C value. So let's look at the typical quadratic sequence. 15, 24, 35, 48. That is my quadratic sequence. So the question is raised now, what is the general term of this sequence? So I will find the first difference and then the second difference, and I will find that there's a constant second difference. So I look at my information. If I get the difference between term 1 and term 2, 24 minus 15 gives me 9. So 3a plus b, the value that we had over here, is equal to 9. And then the difference then between these two is 11. 11 minus 9 gives me 2. So I've got the constant second difference of 2. So 2a is equal to 2. Therefore a is equal to 1. So 3a plus b must be equal to 9. I substitute the 1 in the place of a. 3 plus what will give me 9? So b is 6. Now a plus b plus c is equal to the first term, which is 15. So therefore I will say 1, which is my a value, 6, which is my b value, 7 plus what is going to give me 15. Therefore c is 8. So if I have to give then this general term, I will be saying that a t of n is equal to a n squared plus b n plus c. My a value is 1, my b value is 6, and my c value is 8. Alternatively, you could have noticed that this is also written as 16 minus 1 is 15, 25 minus 1 is 24, 36 minus 1 is equal to 35. So 16 is 4 squared minus 1. So the term number being 1, I added 3 to the term number, I squared it, and then I subtracted 1. So it could be written as the term number plus 3 all squared, and then I subtracted 1 from there. So I get, expand this, I get n squared plus 3n plus 3n plus 9. So n squared plus 6n and 9 minus 1 is 8. So I get the same general term without having to follow this protocol. But if I had seen the relationship that this was 16 minus 1, 25 minus 1, 36 minus 1, 49 minus 1, which is a quadratic number pattern. To conclude, I say the following. Be careful if the pattern does not start at the first term. Remember, when it was the first term, all this information was used. If it's going to be the second term, all this information will be used. If it's the third term, this information will be used. So what happens now? If the pattern starts on the third term, I suggest the following. So I'm adding 9, I'm adding 11, I'm adding 13. So going forward, I've got to subtract 7, I've got to subtract 5. So 15 minus 7 gives me 8, and 8 minus 5 gives me 3. So, having said that, I will calculate, and my first term here, because it's the third term, I use 2a is equal to, the constant second difference is 2, but now my first difference here, which was 9, is not between the first and the second term. This is between the third and the fourth term. So the value that we should be using between the third and the fourth term is 7a plus b. So 7a plus b is then equal to 9. Therefore, b will be 2. And then for term 1, it will be 15 minus 7 minus 5. That will give me 3. So a plus b plus c must be equal to 3. So we've got a is 1, b is 2, therefore c is 0. So if I look at the expression, my general term will be n squared plus 2n. But I could have calculated this also without using this information that I have according to this. I notice that this is the general term, will be quadratic. I notice that this is 16 minus 1, this is 25 minus 1. So I could go about it in that manner as well. I will calculate the first term by going back, finding this to be 8 and finding this to be 3. So 3 will be 4 squared, 2 squared minus 1. So a number squared minus 1. But that number is the first term. I need it to be a 2. So that will be 1 plus 1. So it is n plus 1 all squared minus 1. So if I expand that, I will get n squared plus 2n plus 1 minus 1. And then 1 minus 1 is 0. Therefore, my pattern will be n squared plus 2n. The same as I would have when I use this quadratic formula rule that we've calculated. Can you try to calculate the general term for the following number pattern? You may press pause and continue, and when you are done, you can reveal the answer. I trust you got to the answer of t of n is equal to a half n squared plus 3.5 n plus 7. Thank you for watching this video. If you found it useful, please share with your friends. Do not forget to like, comment and subscribe. Turn on your notifications. This will alert you when new content is uploaded. For further assistance, do not hesitate to contact me. Tutor sessions are available online or in person. See you in the next video. Goodbye.